Welcome to our channel. Today we're going to start with a video that will actually be a part one of a series of 3 videos. The idea here is to detail the different effects of social media or digital technologies on the brain. And so the first video we're going to look at brain formation or how the brain matures during life. The goal here is to let you understand why a younger brain is more susceptible to influences during its development. Second video, we're going to look at the current model of cognitive functioning, and we're going to debunk some myths about the different cognitive networks. And the third video will actually be on the effect of digital media, whether it be the concept of brain rot with social media or generative AI. So that's the series we will talk about for the next coming weeks. So let's go ahead with the first video about the formation of the brain. Now, this is a graphic from a studies published in Nature, and it's a bit of a depressing graphic for us adults. You see different curves. Now, these curves represent structures that we can measure on the MRI. So we can measure the thickness of the cortex, we can measure the volume of the cortex, we can measure the volume of white matter. Now, you will remember that white matter are actually the axons, which are the wires of the neurons, the wires connecting the neurons together. And as you can see, all these structures tend to increase quite quickly on this graphic, but eventually they reach a top, and this top is reached at the age of a young adult, around 20 years old. And after that, everything will decrease, meaning everything we can measure structure-wise in the brain with the MRI decreases. So whether it be the, once again, cortex, the white matter, and so on and so forth. That is not to say that the brain function will decrease accordingly, but structure-wise, the brain is at its peak around 20 years old. Now, everything grows fairly quickly, as you can see on this curve. And interestingly, this corresponds to a phenomenon which we call exuberant synaptogenesis. So, sounds complicated? Fairly easy. Synaptogenesis, so formation of new synapses, and exuberant because the process is quite active, meaning that from the 34th week of conception to maybe around 2 years after birth, an individual can form up to 40,000 synapses a second in its brain. So each and every second, 40,000 new synapses are formed, which represent new connection between neurons. So parents take notes whenever we say that a young child is a sponge. It really is the case. A young child is influenced by his environment. So whatever the stimuli to which the brain is exposed will influence the connectivity pattern in the brain, hence the relevance of the environment. There, of course, is a genetic component to this as well. And so far, we don't know for sure what is the contribution of one or the other. But as we don't have any control on this genetic component, we might as well try to maximize the environment component to which our brain are exposed. So it's really important to understand that this process of forming new synapses is preserved during the entire life. When I did my medical studies in the 90s, we used to say that a brain that had reached 25 years of age was complete, and from this age was starting a very slow decline. We have seen that structure-wise this is not false, but interestingly enough, function-wise, It is not the case. And it's not the case because this process of forming new synapses is preserved during the whole life. There are new studies now showing that even in people age 80 years and above, this capacity to form new synapses is preserved. Of course, it has declined. This process is much more active when we are young, but it is nonetheless preserved, meaning that what we actually use as we get older is what we would call cognitive flexibility, in that we have less neurons, we have less neuronal networks to perform a given task, and so we are less prominent to learn. But we still can. The common example I like to give is if I was trying to learn to play piano nowadays. I am 58 years old, so my capacity to play piano clearly is not as good as it would have been if I had tried at 6, but it is still preserved. All right, so, and just to illustrate the fact that what I'm telling you is true, it's not wishful thinking. This is a video. Each and every year there are videos and images that are submitted to different contests, scientific contests, and this is the one that won in 2022 that shows actually neuronal migration. So you can see that neurons are in a state of motion, of continuous motion. They are connecting and reconnecting. Now you have to perceive your brain as something that is very dynamic, always in motion, because that's what it is. And this process of motion is much more active as we are younger, but it remains present during your whole life. Now, we just spoke about exuberant synaptogenesis, meaning we construct, we build synapses at a very high rate as we are very young. Actually, we do so at a point where we have built twice too many synapses when we reach adolescence. So at adolescence, what happens? Well, there's a process that we call synaptic pruning, in which the organism will eliminate all these synapses that have not been used. There are cells that can detect the tonicity of each of these synapses or connection between neurons. And those that have been neglected, that have not been used, hence that have not been very useful, are simply eliminated. Why do we do that? Well, we do that because we need to preserve the metabolic effectiveness of the brain. The brain is extremely effective metabolically in its energy consumption. If we were to keep all these synapses, that would represent too much activity. The brain would be in competition with the rest of the body for energy consumption. Hence, it prune all these synapses that aren't useful to keep those that have been used and that will be used in the future. This process is performed by a cell, a glial cell, which is an oligodendrocyte precursor. Now, you guys remember in the first videos, we did mention that on top of neurons, we have other type of cells in the brain, which we call glial cells. There are different brands of glial cells. One of these brands is oligodendrocyte. Well, there's a specific oligodendrocyte that has as a task to survey all these synapses and degrade those that were not used. Whenever a synapse is used frequently, its proteic content, its structure will actually change. So this is something that can be recognized by these cells, and those that have not been used so much will be eliminated altogether. I need to come back to something that we already discussed in a prior video, which is what we call the Hebbian theory, named by Donald Hebb, which is the Canadian psychologist. which is really the mainstay of modern neurosciences. So Donald Hebb stated that those fires that cell together wire together, meaning that if neurons are activated at the same time and following the same pattern of activation, well, they are likely to be connected and form what we call a neuronal network. That's one of the things that he left us in terms of heritage, but there's more to it. And the other concept that is really relevant to our discussion today is the fact that whenever you repeat a task, you repeat your task, you get better at doing it. You get better at doing it because there is a reinforcement in these neural networks, and this reinforcement happens at the level of the synapse. So your synapse becomes more tonic. It's easier to activate, it's better in its efficiency. And that's what Donald Hebb, that's the Hebbian theory, stating that as you repeat a task frequently, you will get better at it, and you do get better at it because the synapse is reinforced. Equipped with these concepts, we're gonna now venture to the second video, which will explore the different models of cognitive functioning, how these cognitive networks work. We're gonna debunk some of the false beliefs about these networks, and we're gonna explore why these networks can be modified by digital media, whether it be in a good or in a bad way. So thanks for listening. See you in the next video. So that was it for this week. Thanks for listening to us. We have a lot of pleasure producing these videos on the brain, on neurosciences. It's a topic that we do like. We do enjoy the topic. And the goal is really to simplify matters for you guys. So I hope you enjoyed that. You know that it also serves a good purpose in that we are linked to a foundation called Cœur en Tête, which actually support my lab. So my lab does research on brain tumors. We're looking for new treatment strategies. So everything that will be considered a profit on this channel will be sent to the laboratory. So if you like what we do, if you enjoy these videos, do not forget to like the channel, to like the videos, to subscribe, and to click the bell so that you get notifications whenever we get a new video out. Please leave comments as well as questions. If you guys have specific questions on the brain, on neurosciences, and we would be more than happy to respond, to address some of the questions you guys have on the brain. So thanks again for listening. Notice as well that there is a link directly to my internet site that will promote any media activities as well as release of new books. So thanks again for being there.